Okay, so the recording has started. We will start within some seconds. Okay, then we will start now. Good evening, everyone. My name is Chandan Kumar Gupta. I am a Prime Minister Research Fellow in Department of Mathematics, IIT Patna. I am your NPTEL-PMRF Teaching Assistant for the course Probability and Statistics. This course is offered by Professor Somesh Kumar. He is currently a faculty in IIT Kharagpur. So this is the extra session of the 12-week course actually. Uh, Logically, it will be like schedule after the all 12-week courses, live sessions, but we are given a timeline between 3 to 14. And since my last like live session will be held on 14th of April, okay, so I have chosen this 3rd of April for this extra session. Okay, so in this extra session, we will summarize our this course only. Okay, we will try to summarize what we have discussed till date, till now, from week 1 up to week 9 or 10 something you can say. Okay, if you people have any doubt regarding any weak questions or anything, you may ask. Okay, so before starting, let me tell you something about the examination. Okay, so as you people know, the name of the course is Probability and Statistics, and the course code is NOC. It's NOC26. It's MA41. Okay, and the examination type will be like online and computer-based exam. Hope you people have enrolled yourself for the examination. Okay, and the examination will be held at it's 26 April 2026. Okay, the rest of the information you will get on your hall ticket as well as via mail. Okay, the computer based examination, that means you are given questions on computer and you have to enter your answer on computer as well. Okay, everything will be on computer. No need to, you are not given any rough sheets or any, you may given maybe any rough sheet, but you are not need to submit any kind of supplementary sheets. Okay, yeah, that is most probably the question will be like either MCQs type or the filling the blanks type or something that is essay type. Okay, that you can type in computer. Also, you are not allowed to use any physical computer. Yes, NAT, obviously, you are given some numericals, and based on your numericals, you need to solve those numerical and you need to finally put the solved answer in the answer, like in the respective places. Okay, you need to write in the computer. Suppose any question are given like probability of this event, you are solving and then you may find 5 by 9 is the answer. Then you need to write 5 by 9 in the specified place. Okay, the everything will be like communicated with all of you via email, but these are the only things. Okay, computer based exam, you need to write your answer in computer only, filling the blanks type, MCQ type. Next, obviously, numerical type, you need to solve the question and type the final answer in the computer. And it may possible some definitions will be there, so you need to write some kind of essay. Okay, some 2 or 3 para, it may also possible. Okay, because computer based exam can contain these type of question. Okay, so you need to know the concept, the definitions, the statements, if anything. Okay, And the rest, you may ask anything, anytime to me, direct via the this YouTube channel link. Okay, you may comment on the any of the YouTube link, YouTube video. I will definitely try to respond. The discussion forum is also there. I will try to respond from there as well. Okay, or you can directly contact me via LinkedIn, or you people have my email ID as well, probably. Okay. So yes, these are the things. Anything related to the examination, you may ask. Yes, one more important thing is that physical calculators are not allowed. Okay, like you are not allowed to use physical calculators. You are give like there is some option of online calculator is there. Okay, you may use that, but physical calculators are not allowed. Okay, so hope you don't have any doubt from the examination point of view. If anyone have, you may ask. Or not, let's start with our course structure, and then we will try to recap all these last 10 weeks course like syllabus. Okay, and solve some numericals based on all those topics. Okay, so you people have already know about these things. Okay, so it's like in this is a probability and statistic course. Okay, and you people may remember from first to 8 weeks. Okay, we have mainly discussed about the probability theory. Okay, and from ninth week onward we have discussed about the statistical inference part, that is the statistics. Okay, and yes, since we have only completed 10 weeks, so there is 11th week and 12th week live session that will be held on 7th and 14th of April. Okay, so we will discuss some more parts that we have not yet covered on 11th and 12th week live session. Okay, so first 8 week we have discussed about the probability theory. In probability theory, like we have discussed about in week one algebra of sets, random experiment. There are three definitions of probability, like classical definition, the statistical or the statistical definition, that is also called the empirical definition, and then the axiomatic definition of probability. There are different kinds of properties of probability are there. Okay. Then in week two, we will move to the conditional probability, then the independent of events, the Bayes theorem, which is one of the important topic of probability theory. Okay, and I'm not sure, but definitely you will get some numericals based on either Bayes theorem or the conditional probability in your examination. Okay, then then we have discussed about the random variables, the distribution of probability, that is the probability distribution of random variables. Okay, then we have discussed about the moment characteristics of distribution functions, spatial kind of discrete distribution. These have been discussed in week three actually. Okay, different kind of discrete distributions are like the Bernoulli distribution, the binomial, the Poisson distribution, geometric distribution, negative binomial, hypergeometric, and so on. There are many distributions that has already been covered in week three lecture. That has already covered in like very comprehensive manner, and we have also solved some numericals based on these topics in week three. Okay. Then successively in week four, we have discussed about the continuous distribution like exponential, beta, gamma, uniform, double exponential, variable, log normal, etc. Okay, these are, and obviously we have solved, we will we have first discussed about the properties of these distribution, that is the skewness, the kurtosis, the mean, the variance, etc. of these distribution. And then we have solved numerical based on these topics. Then in week five, we have comprehensively discussed about the normal distribution, the properties of normal distribution, the problems related to the normal distribution, the transformations of normal distributions had also been discussed in week five and week six, actually. Okay. Function of random variables, the joint distribution, the independence of two random variables, these have been already discussed up to week six. Okay. One more thing has been also discussed in week six, that is the correlation coefficient. Okay. And also the linear property of correlation coefficients have also been discussed in week 6. Any kind of info thing you want to discuss, you people have any kind of doubt up to the previous week's syllabus or any questions, you may ask it. Okay. Then yes, we will move from, we have moved from univariate distribution to bivariate distribution in week 7. Okay. And we have mainly focused on bivariate normal distribution, the additive property, the transformation, and yes, the distribution of order statistics. Okay. Then in week 8, the last topic, you may say the last topic of probability theory, that is the sampling distribution, that is the small sampling distribution or the exact sampling distribution is also termed as. Okay. Then in which we have discussed about the T distribution, the F distribution, and the chi-square distribution. Okay. In all these T, F, and chi-square, you people may remember that there is no parameter involved. There is degree of freedom involved in these kind of distributions. Okay. That is called small sampling distribution. That is also called exact sampling distribution, or in short, sampling distribution. Okay. So up to week 8, we have discussed probability theory. Now, in the week 9, that is the second last classes. Okay, the second last class. In that class, we have discussed about the descriptive statistics, in which the measure of central tendency, measure of dispersion, measure of skewness, measure of kurtosis has been discussed. Then, obviously, the introduction to the estimation theory. Okay, which is totally the part of a statistical inference. Okay. So in estimation theory, there are two types. We have this. We define the statistic. What is parameter? What is statistic? What is estimator? What is estimates? These are the terms used in statistical inference. And then obviously the properties of a good estimator, that is unbiasedness, sufficiency, consistency, efficiency, completeness. These are some of the properties of a good estimator. Then we have discussed about the estimation techniques. Okay. And in estimation techniques, we have mainly discussed about the least square estimation, the method of moment estimation. Then we have solved some numericals based on these methods in week 9. And in the last week, that is in week 10, we have discussed about the maximum likelihood estimation techniques, which is one of the most finest estimation techniques in classical estimation or frequentist approach. Okay. And then we have also solved numericals, like numericals based on the classical, like maximum likelihood estimation. Then we have also discussed about the uniformly minimum variance unbiased estimator. Okay, uniformly minimum variance unbiased estimator. Then two more properties of a good estimator, like sufficiency and completeness, and efficiency also in week 10. In last week, we have also discussed about the efficiency, sufficiency, and completeness. And then we have learned about two theorems, two very important theorem of our statistical inference. That is the Rao-Blackwell theorem and the Lemon-Chaffee theorem. Okay. And then these are, up to this point, these are the topic related to the point estimation. Okay. In statistical inference, we divided the statistical inference in two parts mainly. People may remember the point estimation, the interval estimation. Okay. And the third part is also there. That is the testing of hypothesis. Okay. So up to this point, up to week 10, we have discussed about the point and the interval estimation technique. Up to this point, you people have any doubt you want to ask and discuss anything, you are welcome. If not, we will move to 11th and 12th week on the 7th and 14th week, 14th April. Okay. And we will definitely discuss about the introduction to testing of hypothesis, the definition, the terminology used in testing of hypothesis, the powerful test, the definition of what we call a most powerful test, that can be discussed in week 11, and then numericals and applications of these testing of hypothesis in week 12. Okay, so week 11 and week 12, like in these 2 weeks, we will discuss about the testing of hypothesis concept, the numericals, the properties, the basic definitions, etc. Okay, so these are the syllabus. Okay, you need to know about all these things before going to examination. Okay, you people may there will be questions like define the different kind of errors, which error is dominating or which error is harmful, define in real life scenario where you can observe the testing of hypothesis concept, any kind of thing you may ask. You people need to know during the examination. Okay. So yes, I'm just trying to revise from week 1 to maybe week 9, 10 up to. Okay. We will solve some numericals based on those topics from week 1 to week 9 or 10 because it is actually summary session. Okay. So we will try to summarize all those things that we have learned till date. Okay. Any kind of question you people may ask. Okay. So let me start with question 1. Before that, anyone have any doubt up to this point? Anyone?
No, sir.
Okay. So let me start with question 1, the basic question from week 1. Okay. And that is the probability. Okay. We are like random experiments. We perform a random experiment. The kind of random experiment is we roll a pair of dice. Okay. And write down the outcomes. Then we define some events based on those outcomes and find the probability. Okay. This is the simple question. So let me write the question. You need to find the probability of turning 4 at least once. At least once in 2 tosses of a fair die. Okay, the singular word is DIE, die, and the plural is dice. Okay, so we need to find the probability of turning, it's turning up 4 at least once in 2 tosses of a fair die. Okay, if you people may try to visualize the sample space. Obviously, you may find it's 1, 1, 1, 2, 1, 3 up to 1, 6, 2, 1, 2, 2, 2, 3 up to 2, 6, and so on, up 6, 1, 6, 2 up to 6, 6. So there is a total of 36 possible outcomes. Okay, when we throw a pair of dice, then we have a 36 possible outcomes. Okay, so I'm not going to list down all those, but okay, so like our random experiment is tossing a pair of dice twice or tossing 2 pair of dice. Okay, pair of dice, not pair. So the answer will be like 1, 1. It's 1, 2 up to 1, 6. Then it's 2, 1 up to 2, 2 up to 2, 6, and so on. And then at last it's 6, 1. It's 6, 2 up to 6, 6. Okay. So obviously the number of element in our sample space will be 36. Now the question is turning a 4 at least once. Okay. So yes, we have 2 dice now. 2 die, I mean 1 and 2. So let me define some events related to those. So let even. Even is like event 4 occurs on the first toss or on the first die, obviously. Event 4 occurs on first toss. Okay. And E2 similarly. Event 4 occurs on second toss. So obviously, you people have idea that on first toss, event 4 occur. How many times event 4 occur? And what is the probability on first toss? Obviously, out of 6, there is only 1. So that is probability that even That is, event 4 occurs on the first toss. There are 6 possibility when we roll a die once. There are only 1 out of 6 possibility to occur 4. So that means obviously it's 1 by 6. In the same manner, probability of E2 has also equal to 1 by 6 probability. Okay. Now we need to find at least once. Okay. At least once, and there are one more possibility that 4 has occurred on first as well as on second. So that event is included in E1 and E2 both. Okay. Let me write if you like. It's 4-1, 4-2, it's 4-3, it's 4-4, it's 4-5, and then it's 4-6. That is belongs to E1. Na? And similarly from E2, obviously 1-4, 2-4, 3-4, 4-4, 5-4, and 6-4. Okay. So it is clearly seen this happens twice. This is repeated. No? So that means what? That means we need to find the E1 intersection E2. And that is nothing but our 4-4 event. Okay. And yes, E1 intersection E2, when we consider both events simultaneously, we have 36 observation, and out of those 36 observation, there is only one observation that is belongs to E1 intersection E2, that is 1. Okay. So up to this point, everything is cool and everything is okay. Now we need to find at least once. And what is the meaning of at least once in like set theory or probability theories? In union, you people may remember, it's nothing but union. So that means what? Now we need to find the E1 union E2. And the meaning of this is like first has 4, second has 4, and or not use and. Okay. Like first toss has occurred 4 plus, not, I don't need to write plus, I need to write or actually. And second toss has 4. Okay. So I need to write or. The union is defined as or, either first or second. Okay. So this is the case. So obviously, the number of element in even in EQ is like you can directly count here 12 minus 1, that is 11. Okay. So now you may solve by help of any means, like we have the problem. You can directly solve either 11 upon 36. Okay. Which is our favorable outcomes. This is our favorable outcomes. Or you may solve by using the formula, since we know that probability of A union B is what? Probability of A plus probability of B minus probability of A intersection B. So obviously, probability of E1 union probability of E2 is probability of E1 plus probability of E2 minus probability of E1 intersection E2. And this is what? This is probability of E1 is 1 by 6. That has already been told here. Okay. So it's 1 by 6 plus again it's 1 by 6 minus it's 1 by 36. If you know, remember, it's 1. So intersection has 1 and the total amount sample possible sample size is 36. So that is what? That is 36 is 6 plus 6 minus 1. So probability of E1 union E2 comes out to be 11 upon 36. Okay. So this is our required answer. Also, you can solve directly from here from here, but it is not possible to find the favorable number of outcomes all the time. So that's why you need to know how to use this formula as well. Okay. Obviously, I don't think any doubt will. Okay. Now we will solve the next question. Okay. Wait, sorry. Please ask when you have any kind of doubt without feeling anything. Okay. Now one more question. We are given 4-digit numbers are formed. 4-digit numbers are formed. Selecting randomly digits out of selecting randomly digits out of 0, 1, 2, 3, 4, and 5. Okay, without repetition. Okay. Now the question is, what is the probability that a number is divisible by 5? We need to find what is the probability that a number is divisible by 5. Okay, so this is the question. Okay, this is the question now. So we need to find the number of 4-digit number that can be formed first. And then obviously we can solve the favorable, that is out of those formed 4-digit number, how many numbers are divisible by 5. And then obviously we can at last take the ratio, find the required probability. So yes, first thing is we are given the digits like 0, 1, 2, 3, 4, 5. Okay. And we need to form a 4-digit number. So obviously any number is said to be 4-digit, which starts from like not 0, na, from 1 to 9. Okay. So that means what? Suppose this is the like ones, this is tens, this is hundreds, and this is thousands. Okay. So obviously, for any kind of 4-digit number, how many possible outcomes are there for possible numbers are there for thousands? Obviously, we are given 6 numbers: 0, 1, 2, 3, 4, 5, and 6. Out of those, only 5 numbers are possible. We can write here. Okay, and since it is formed without repetition, so that means at hundreds we have either out of 6, since 1 is used at the 1000th place. So that means out of those 6, 1 has been already used. And then there are 5 possibility for the 100th place as well. Then obviously 4 and 3. So the total number of possibility will be like what? It's 5 into 5 into 4 into 3. So that means 100 and 3, 300. So there will be a total of 300 numbers can be formed from 0 to 5, which is a 4-digit number. Okay. And now the next question is, this is a total, this is a possible outcome. Okay. Now the next step is to find the favorable outcome. So this is our total outcomes. Now our favorable, that is divisible by 5. So yes, a number is said to be divisible by 5 if its unit place has either 0 or 5. Okay. So that means we have two possibility now. Okay. So we have two possibility now. Na? The first possibility is like what? Suppose we have, yes,
But
Ayush, do you have any
uh,
question? Yes, sir.
yeah, sir, sorry to interrupt, but I would like to know that what's you have given the logic behind you have put in two simultaneous five number at 100 place and at 1000 place as well. So like
Yes.
like I would like to know the logic then. Again,
Yes,
sorry if
yes.
I
Okay.
missed something.
Okay, no problem. See, we are given 6 digit only 0, 1, 2, 3, 4, and 5. The 6 digits are there. With the help of these 6 digit, we need to form a 4 digit number. Okay. And any number is said to be 4 digit when it start with 1 to 9 number, na? Either 1 or 2. Suppose I am writing 100 or 123. What I said, it is a 3 digit number. If I write here 0, then again it is a 3 digit number. It's not going to be a 4 digit number. Okay. So any 3 digit or 4 digit number is starting with either 1 or 2 or 2 9. So we are given 0 to 5, 0, 1, 2, 3, 4, 5. So the number at the thousandth place, the number at the thousandth place will be not 0. Na? It may either 1 or 2 or 3 or 4 or 5. Okay, so we have five possible numbers, five possible candidate only. So that's why I've written here 5. And since the question said we need to perform this random experiment by applying without repetition concept. Okay, since we are not going to use repeated numbers, so suppose out of these 5, I have used 4. Okay. Now, the possible numbers that can be used at 100th place will be either 0 or 1 or 2 or 3 or 5. So that's why I have put 5 and 5 at 10th, sorry, at 1000th at 100th both places. Is it okay? Is it okay up to this
Okay, got
point?
it, sir.
Okay. Let me erase those things. Okay. Okay, now. So again, now in favorable cases, the number have to be divisible of 5. Okay. So that means the number is divisible by 5 if its unit place has either 0 or 5. Okay. So we have two possibility. The first is the unit place has 0 and the unit place has 5. So the number is 1. Okay, let me write in this manner. So it has one possibility and one possibility, that is 0 and that is 5. Okay. The unit place has 0 and the unit place has 5. So suppose the unit place has 0, in that case, the 0 has already been used at the unit place. So at thousandth place, I can use 1, 2, 3, 4, 5, any numbers out of those. So the possibility, the number of possibilities like 5, and then obviously the 4, the 3, and the 1. So that means what? 5 into 4 into 3, that comes out to be what it 60. Okay, it becomes 60. 5 into 4 into 3 becomes 60. Now, since we have used 5 at the unit place, 5 at the unit place, so that means what? That means what? That means this number has been used actually. This number has been used at unit place. And since we do not repeat the same number, how many possible numbers can be used at the 10th place? Obviously, either 1 or 2 or 3 or 4. We can't use 0 at the, not 10th, sorry, 1000th place. So here we have a 4 possibility. In the same manner, at the 100th place, we have again 4 possibility and then 3 possibility. So the total possible number can be formed by 4 into 4 into 3, that equals 48. So all those numbers, the total divisible the total number digits, no, number divisible by 5 or divided by 5 is what? It's 60 plus 48, which is equal to 108. Okay, so this is our favorable outcomes. Out of these 300 numbers, 108 numbers are those numbers that is divisible by 5. Now the question is simple. The probability is what? The probability is favorable outcomes upon total outcomes. So that can be divided by 12, 12, 9. Okay. And then 12 is obviously it's a 25. So 9 by 25 is our final answer. Is it okay up to this point? If you people have any doubt, please ask. Okay. So yes, this is how we can solve this kind of question. Now the next question. Okay, the up to the first two question is related to the week one actually. Okay, now it's I am discussing about the week two question. Now the next question is like, if B is a subset of A, if B is a subset of A, then the probability, then probability of A given B is equal to a simple question. Okay, you need to solve the probability of A given B. And yes, we know that this is a conditional probability now. Since probability of A given B is equal to probability of A intersection B and divided by probability of B. This is the formula. Now, uh, now since we are given B is a subset of A. B is a subset of A implies what? B is a subset of A means every element that is related to B had also related to A. Okay, all the not that means obviously every or all the elements that belongs to B must belong to A as well. So this implies what? This implies A intersection B is actually B, because all elements are B as contained in A as well. But it is not necessary that all elements of A contained in B. Okay, so A intersection B comes out to be B here, and this implies what? Probability of A intersection B is actually probability of B. Now, the probability of A given B is what? Probability of A intersection B upon probability of B. That is probability of B divided by probability of B. That is nothing but the answer will be comes out to be 8. Sorry, 1, not 8. Okay. So if B is a subset of A, then A given B is nothing but comes out to probability of A given B is nothing but comes out to be. Okay, the simple probability, the simple property of set theory or probability theory. Okay. Now the next question is like, okay, this is again weak second question. Okay, the question is like, an urn contains 6 white and 4 red balls. 6 white and 4 red balls. Okay, a ball is drawn randomly and put aside. The ball is drawn randomly and put aside without noticing its color. Without noticing its color. Then one more ball is drawn. Then one more ball is drawn. Okay. And it is white. Now the question is, what is the probability that the first ball is white? The question is, uh, what is the probability that the first ball is white? Okay, it's a simple question. Maybe you people can find out by reading this question that it is nothing but the Bayes theorem. Okay, the question is related to Bayes theorem. Obviously, it is a conditional probability. Okay, and the Bayes theorem is what? We have like E1, E2, and EM kind of exhaustive events. Okay, the exhaustive events, that is, those events are the union of those events comes out to be the sample space, and the intersection comes out to be phi. Okay, those kind of events are said to be exhaustive events. So we are given exhaustive events. Okay, and there is one more event related to those all exhaustive events that are called likelihood event actually. Okay, so here we need to find out the likelihood event and the exhaustive event first, and then we will use the Bayes theorem. Okay, and find out the probability. Here it is clearly given. We first draw a ball and put aside. So that means what? Uh, that means put aside. That means we take the ball and then without replacement. The overall concept of this question is like without replacement. We first take one ball and put aside without noticing. Then we draw the second ball and then find out the second ball is white. Now the question is, it is white. Now the question is, find the probability the first ball is white. Okay. So let's define the events. Okay. The events is like E1. E1 is like, well, the first ball is white. And E2 is like what? The second ball is white. Sorry, second ball is not white. Second ball is obviously the likelihood event actually. The first ball is red. There are three possibilities. Na? So we have either white ball in the first row or the red ball at the first row. So obviously the probability of E1 is what? The number of white ball is 6. The total number of ball is obviously 6 plus 4, that equals 10. So the probability is 6 by 10, and probability that E2 is 4 by 10. Okay. So here E1 and E2 is our exhaustive events. Okay. Here E1 and E2 are our exhaustive events. Okay. Now the next is what? Now the next is we need to find the likelihood event. Okay. And that is, let me write A. And the A event is like second, it is already given. The second ball is white actually. That is given. We need to find the second ball is white. First thing is we need to find the second ball is white. Then we need to find the conditional probability that the second ball is white. Then what is the probability that the first ball is also white? Okay. So obviously the total law of probability is used, and then at last the Bayes theorem is used. So let's start. Yes, the probability that A given E1, that is the second ball is white, given that the first ball is white. Okay. So the second ball is white. The second ball, there are total 6 white and 4 red balls. Okay. 6 white and 4 red balls. Okay. The second ball is white, given that the first ball is white. So the first ball is taken as white. It is our like the first ball is taken. So now without replacement. So that means now the urn contain 5 white ball and 4 red balls. So the total number of ball is 9 there. Okay. And then the second ball is white is like what? 5 white ball is there in the urn and out of 9 balls. Okay. Out of 9 total number of balls, 5 balls is there and can be removed or drawn. Similarly, A given E2. The first ball is red. Then what is the probability that the second ball is red? In this case as well, the total number of ball is 9 because 6 white ball is there and 4 minus 1, that is 3 red ball is there. So that means total number of ball is 9 again, and the favorable number of ball, that is the white ball, will be 6. So these are given. We need to find the probability that the first ball is white. We need to find the probability that the first ball is white, that is the even, given the second ball is white, that is A. We need to find this probability. And yes, we know that probability of probability of EI given A, the base theorem, obviously I'm going to write the base theorem. The probability of EI given A is probability of EI into probability of A given AI, and whole divided by probability of EI into probability of A given AI, and it is taken summation over all I. Here the value of I is 1 and 2 only. There's 2 possibility. Okay. So let's solve the numericals. So it is like what? Probability of even given A is our probability of even into probability of A given even, whole divided by probability of even into probability of A given even, plus probability of E2 into probability of A given E2. Up to this point, everything is okay, I think. Okay, I'm just putting the formula. Now, probability of even is what? Probability of even is 6 by 10, E2 is 4 by 10, A given even 5 by 9. Okay, so it's 6 by 10 into A given even is 5 by 9. Obviously, it's 6 by 10 into 5 by 9 plus probability of E2 is like 4 by 10 into it's 6 by 9. A given E2 is like 6 by 9 by 9. So this is the case. Now you need to solve, nothing else. So it's 30 upon 90. It's 30 upon 90 plus it's a 24 upon 90. So obviously 90 has been cancelled out. It's 30 upon 30 plus 24 comes out to be a 54. Now it can be solved and the answer will be like probability of even given A is 6. 6 fives are and 6 nines are. So it comes out to be 5 by 9. Okay. This is our required answer. Hope this clears the question. Any doubt up to this point? Anyone? Okay, then we will solve next question. Okay, so up to week 2, we have complete scroll up. Okay, do you have any question? From which question can you please tell me? This
No,
is the
sir.
question.
Actually, I just want to jot it down.
You just want to?
I'm just writing, so like so just
Okay, okay, okay. You can take, this is the question. Just try to solve by yourself, then it's better. Okay. Okay,
uh,
then is it okay? I can move forward.
yeah.
Now the next question is based on the week 3. Okay, that is obviously with the discrete distribution. Obviously, the problem related to our discrete distribution case. So the question is Simple. Okay, you need to know about the distribution, the definition, that means the form of the PDF, then its mean, its variance, its skewness, its kurtosis, that has already been discussed in week 3. There is one question that I am going to solve here. The given question is the probability of a product produced by a machine to be defective is, the question is the probability of a product produced by a machine, produced by a machine by a machine to be defective is 0.05. That means 5% of the product is produced defective by a machine. Then 10 products are taken at random. We are given 10 products are taken at random, and the random variable x denotes, and the random variable x denotes the number of defective products. Number of defective products out of 10, obviously, since we are taking 10 products, and out of those 10 products, the number of defective products can be is denoted by the random variable x. Then the mean and the variance. Find mean and variance. Find the obviously mean and, let me write here, variance. Okay, the simple question. Now this kind of question you may probably get in examination. Okay, there is no mention of the distribution. Okay, so when we are discussing about the number of products, obviously it is either 1 or 2 or 3 or 4 or 5 kind of. So that is totally a discrete kind of distribution. The first thing is clear. Now the next thing is, here we are given the number of trials, the number of products that is defective is a random variable. Okay, that is our number of trial is random variable, and the total number is given 10. So this is a scenario for the binomial distribution. Okay, just try to recall. You may realize that this kind of scenario is discussed during the problem of binomial distribution. Okay, so yes, it is a problem related to the binomial distribution. So we will solve accordingly. Okay, here it is clearly seen that this x, which is our the number of defective items or defective products. Okay, this means x follows our binomial distribution with n and p. Okay, so the n will be here given 10. The total number of trial is given as 10, and the probability, that is the probability of success. See, the meaning of P is probability of success. Okay, but here the probability of success means the defection. That is the defective probability. Okay, so keep this in mind. Okay, the probability of success here is P, and our interest, interest of you can say our study of interest is to find out the defective item. So that is the success probability. Here it is 0.05. These kind of, maybe you people may sometimes getting confused related to this topic. So yes, probability of success is getting defective item, and the probability of getting defective item is 0.05. That is 5%. So the value of P is 0.05. And since X follows binomial, X follows binomial NP, then in that case, you may realize the probability mass function is written as like what? NCX, P to the power X, 1 minus P to the power N minus X. Here X equal to 0, 1 up to N. the P is belonging to 0 to 1, excluding both. Okay. And yes, this is the case. And yes, in that case, expected value of X is NP and the variance of this X is NP1 minus P. These have already been discussed. I'm not going to derive anything. So yes, you can put the value directly here. So the expected value of X is NP. That is N equal to 10 into P equal to 0.05 comes out to be 0.5. Okay. And then variance of X is what? It's NPQ. Q is actually 1 by P. Okay. NP1 minus P. It is 10 into 0.05 into 1 minus 0.05, 0.95. Okay. You may solve this. Probably this value comes out to be very small number. I'm not having the solution here. So it's 0.5 into 0.95. So it comes out to be what? 0.475. 45, 90, 475. Yes. So it comes out to be 0.47. So this is our answer. Okay. The simple question. You need to know the probability mass function, then the mean, the variance, the moment generating function, and then the skewness and kurtosis. Okay. You need to know these things. So any doubt up to this point? Okay. We will solve the next question. And the next question is again related to one discrete kind of distribution. The question is the probability of a success in a single trial. The probability of a success in a single trial is 0.05. Again, how many trials are needed on the average? The question is like how many trials are needed on an average to get the first success. Anyone who can help me with finding the distribution? See, the question said the probability of or discussing about the first success. Huh? The first success means this question belongs to a geometric kind of distribution. Okay, so that is when we are discussing about the first success after a many number of trials. That is nothing but the question related to the geometric distribution. Okay, and if instead of first success I am taking the third success, the seventh success, then it is from geometric to negative binomial distribution. But in negative binomial distribution, when we uh, consider the number of success as one, then it convert into a geometric distribution. That means geometric distribution is a special case of negative binomial distribution. Always keep these kind of properties in mind. Okay. So yes, this question belongs to the geometric distribution. So that means X belongs to geometric distribution, and geometric distribution has only one parameter, that is P, that is probability of success. Here the P is given here. Na? Here P is given 0.05. So I'm writing here directly. Okay. Now again we need to know the probability mass function for the geometric distribution is what? It's q to the power x minus 1 and P. In this case, the total number of trials is x. The total number of trials is x, and out of those x, x minus 1, q to the power x minus 1, the q is nothing but 1 minus P. Here q is actually 1 minus P. Okay, and yes, this is the case. And x is 1 to up to infinite number of times. Suppose you are tossing a coin and you stop tossing the coin when you get the first head. And there is a very unlucky chance for you that at all the time when you toss first time, second time, every time you got tail. Okay. So you don't know after how many times you will get the first head. Okay. Empirical probability says the second time you will get the first tail, but it is not the case. Okay. So yes, q to the power x minus 1 is the q times you failed to get the first success. You failed to get the head. Okay. Sorry, it's x minus 1 times you fail to get the head. And once you get the first head, you stop the experiment. So this is the case related to the primitive distribution. Now, in this case, in this form, the expected value of x is what? How many trials we need, no, actually? How many trials we need? The expected number of trials. X is the number of trials. So EX is expected number of trials. So the expected number of trials is in this form is 1 by P. And yes, we are given P equal to half. Sorry, it's 0.05, not 0.5. Okay. So yes, expected number of X is actually 1 upon 0.05. And this comes out to be expected number of X is 20. I'm writing here. People obviously understand these things. Okay. So the expected number of trials to get the first success when the probability of success is 5%, obviously 20. Out of 20 times, you may probably get the one success. Okay. This is the aggregate nature, not the individual nature. It may possible that on the first trial you get the head. So that doesn't mean the probability of getting head is 1. Okay. On a long run, the probability of getting head is half, the probability of getting tail is half. On a long run, the probability of getting 1 when you roll a die is 1 by 6. It may possible on the first roll you get 1. That doesn't mean the probability of 1 when you roll a die is 1. Okay. So on a long run, these are the cases. Okay. So this is the case. Now, the next question is related to, again, the Poisson distribution. Any question? The next question is like in a book of 520 pages, (390) typographical errors occur. 390 typographical errors occur. Okay. Assuming Poisson law for the number of error per page, assuming Poisson law for the number of errors, number of errors occur per page. Okay. Find the probability that, the question is find the probability that a page will contain no error. A page will contain no error. Okay. Page will contain no error. This is the question. Now, it is already mentioned here in the Poisson law. Always remember, there is a very minute difference in question. When you see the question, you may get confused, like which distribution is used, either Poisson distribution or binomial distribution. Most of the time, this kind of problem you may face. Okay. So the Poisson distribution, we use the Poisson distribution when the number of trial is higher, large, and the probability of success is kind of small. Okay. This is one case. Okay. Another case is when we are discussing about the rate kind of thing. When we are given a rate kind of information from the question, instead of using binomial distribution, always try to use Poisson distribution. Okay, this is the case. So here it is given in a book of 520 pages. There are 520 pages in a book, and out of those, there is only 390 typographical error on the book, the whole book. It may possible the 7 mistakes will be there on the first page, and there are many pages that contain no error. Okay, this is possible. This is a general scenario. So yes, the rate. What will be the rate? Okay, so the rate is what? Rate, that means the probability, or not the typographical error per page. Okay, the rate is what? The rate means the error per page. Since the error is not quite, the error is less as compared to the number of pages. The error will be like 390 total number of error, and total number of pages will be this. So the rate, that can be also denoted by here lambda, because the rate parameter is lambda in case of Poisson distribution, is what? It can be divided by 130, then it's 3 by 4 or 0.75. This is the rate. Okay, so this is our rate. Now we are given here it is given I think the number of error is Poisson law follow. The number of error occur per page, that is the rate. This rate follow the Poisson law. So that means here x, which is the number of error per page. And this x follows our Poisson with the parameter lambda, the rate parameter lambda, which is equal to 3 by 4 here. Na? So we have the question. Now we need to find the probability that a page contain no error. So it's simple. Na? Probability that the page contain no error, that means x is equal to 0. And this is what? Before writing this, we need to find what? We need to find the probability from mass function of the Poisson distribution, that is e to the power minus lambda, lambda to the power x upon x factorial, when x equals 0, 1, 2, and so on, lambda is greater than 0. Okay, these are the case. Okay, always write the support and the range of the parameter when you write the probability mass function or probability density function. Without these values, there is no valid distribution. What if I use lambda belongs to R? Then this is not a valid probability mass function. So you need to write the range and the support of the random variable as well. Okay. Now, yes, the probability that x equal to 0 is what? E to the power minus 3 by 4. It's 3 by 4 whole to the power 0. It's 0 factorial. So 0 factorial comes out to be 1. Any number, positive number to the power 0 comes out to be 1. So the probability that the number of page contains 0 error is e to the power minus 3 by 4. You may solve this value via any calculator. So this is our answer. Okay. Any doubt up to this point? Okay, now the next question is related to another distribution, that is actually exponential distribution, which is obviously a continuous kind of distribution, not a discrete kind. So the given question is, if x have exponential distribution, if x has exponential distribution, is there anyone who are typing anything? Okay, no. Okay. So if x is a random variable, has follow exponential distribution with mean 1 by lambda, then find probability that x is greater than 3 given x is greater than 1. This is the case. Okay. So simple. It's a conditional distribution, conditional probability we need to calculate. So we can calculate directly. Okay. And This is what. So here it is given x follows exponential distribution with mean 1 by lambda. Okay. So obviously its mean is 1 by lambda. That means it's lambda, because the here now I write this form. Okay. The standard notation for a probability density function. That means a random variable which is continuous in nature. Okay. Then fx lambda. So it's lambda e to the power minus lambda x. If this is the form of the exponential distribution, then the mean value is 1 by lambda. Okay. And yes, lambda is greater than 0, x is greater than 0. This is the proper PDF. Now, the expected value in that case is 1 by lambda. And let me write the variance as well. It is 1 by lambda square. Okay. So this is the case. Now, the next is to find the probability. Simple. We need to find the probability that x is greater than 3, given x is greater than 1, equals the conditional. Obviously, A intersection B. I'm not going to write the formula. Probability of A given B is probability of A intersection B divided by probability of B. The probability of x is greater than 3 intersection x is greater than 1 divided by probability of x is greater than 1. Simple. Now, it's a simple probability. You may find one thing. Suppose it's a straight line. Okay. And it's 0, it's 1, it's 2, it's 3, it's 4. So any number that is like x is greater than 1 is this kind of number. This number. And x is greater than 3 is this number. So this, from this, it is common. Na? So x is greater than 3 intersection x is greater than 1 contains x is greater than 3. So that implies what? So that implies probability of x is greater than 3 given x is greater than 1 comes out to be what? Probability of x is greater than 3 divided by probability of x is greater than 1. Simple. Now, this can be like what? So x is greater than 3 means 3 to infinity. It's lambda x to the power minus lambda x. By written lambda, no? Yes, minus lambda x is there, dx. And the next is again 1 to infinity, lambda e to the power minus lambda x dx. Okay, I'm not going to solve this because this is nothing, just a simple integration. Okay, we have many questions actually, and we have less time. So I'm not going to solve this. You can solve this like lambda will be cancelled out, then x to the power minus lambda x. Okay. Okay, there is one mistake. It's not x to the power, it's e to the power minus lambda x. Okay, lambda e to the power minus lambda x. So e to the power minus lambda x, the integration of that is minus e to the power minus lambda x divided by lambda. Okay, so you can solve this. I'm not going to solve this. After solving, you will find the probability that x is greater than 3 given x is greater than 1 comes out to be e to the power minus 2 lambda. Okay. Solve by yourself. Okay. How you will solve? Just take integration. Solve your integration. Now, yes, there is one thing that I want to clear. When we discussing about the then we have discussed about the exponential distribution. You may remember there is a memoryless property actually, and there are only two distributions that follow the memoryless property. In continuous distribution, it is exponential distribution, and in discrete case, it is geometric distribution that follow the memoryless property. So yes, it can follow the memoryless property. That means we can solve the numerical from the with the help of the memoryless property as well. Okay. Now, by using memoryless property, that is also called lack of memory property. And what is its property? Is the probability that x is greater than m plus n given x is greater than m this probability is actually probability that x is greater than n. Okay, this is the memoryless property that has already been discussed twice. Okay, so in week 3rd and week 4th, you can go and see. Okay, so yes, we are given the probability that x is greater than 3, given x is greater than 1. So that means what? Probability that x is greater than 1 plus 2, given uh, given x is greater than 1. So that means what? This is nothing. Using the memoryless property, we can write it like probability that x is greater than 2. And yes, it's an exponential. So it's nothing but e to the power minus twice of lambda. Simple. Okay, so you can directly solve via this formula or this approach as well. Okay. Any doubt up to this point? Okay, then the next question, I'm just solving, just giving you some concept. Okay, these are already been discussed. Now the next question is like, okay, this is related to the beta distribution. If x follows beta distribution with parameter 4 and 4, then what is the mean of x? Then find expectation of x. Okay, you can directly solve if you know the expected value of random variable x when x follows the beta distribution, or you can solve and find the answer. See here, I'm just going to solve. Okay, so if x follows beta distribution with parameter m and n, suppose m and n, then in that case the mass function is like, sorry, the density function is like 1 upon its beta function mn. Let me write beta here, beta mn, and then it is like x to the power m minus 1 and 1 minus x to the power n minus 1. The x belongs to 0 to 1, and obviously the mn is positive. Okay, this is the uh, beta distribution of first kind actually. Okay, there are two kinds of beta distribution. This is the first kind in which x to the power m minus 1 multiplied by 1 minus x to the power n minus 1. And in the second kind, it is x to the power m minus 1 kind of thing. And then the denominator contains 1 plus x to the power something, m plus n. Okay, maybe I missed some maybe sign. And yes, the value of x, the range or the support of x in the second kind is 0 to infinity. Here the range contains 0 to 1 only. But in another kind, it is 0 to infinity. Okay, so always keep this in mind. Okay, so in that case, you may directly know the expected value of x, but I'm not going to solve this. I'm going to solve in general case. So the expected value of x is what? Integral over x. It's x into fx dx. Okay, this is the case. So integral value of x is what? It's 0 to 1. It's x into 1 upon beta function. And then it's like x to the power m minus 1. The m values given here is 4. 4 minus 1. And 1 minus x to the power again 4 minus 1 dx. Okay. So here actually x is multiplied. So if you are going to see, you will find 0 to 1. It's 1 upon beta mn. So beta function will be taken right from the integral. Okay. So it's 0 to 1. It's x to the power 4 minus 1 into x. So x to the power 5 minus 1 actually is that. And then 1 minus x to the power 4 minus 1 dx. So this is actually our beta function. Okay. There is a beta function. The value of beta function, this value actually means this is actually beta function, and this value is our beta m, beta 54. Okay, so it's beta 54, it's beta mn. Okay, let me write one more thing here. I need to write the value of m and n here. So that is our actually 4 and 4. No? Okay, I'm just putting the value of m and n as equal to 4 and 4 and beta 54. Also, since beta mn equal to, it's like gamma m gamma n upon gamma m plus n, and gamma m equal to m minus 1 factorial. Okay, these are the two formula that we are going to use. Okay, so that means what? So that means it's beta 54 is like what? Gamma 5, gamma 4 upon gamma 9, 5 for 4, multiplied by it's gamma 8 because it's 4, 4. So gamma 4 plus 4, gamma 4 and gamma 4. I'm not going to solve these things that you can solve directly and find out the value is 1 by 2. Okay. Also, if x follows beta mn, then expected value of x is actually, okay, I think it's n upon m plus n. Okay, I'm getting confused now. Probably it's m upon m plus n. Please verify this. Okay. I think it's m upon m plus n. So that means 4 upon 4 plus 4 comes out to be 1 by 2 directly. If you know the formula, then directly you can solve. And if you don't know the formula, you may follow the definition of expected value of x and finally solve the answer. Okay. Up to this point, any question? Okay. If not, then we will solve some more question. Now the next question is related to MGF. Okay. The moment generating function. The MGF of a continuous random variable is, we are given the MGF of a continuous random variable is, we are given like it's mxt, which is equal to 1 minus 2t to the power minus 1. Now find probability that x is greater than 1. This is the case. Okay. So so the case is, okay, sorry, need to use some more dark colors. Sorry, related the green one. Okay. So the question is here mxt. We are given the moment generating function. Okay. The moment generating function has some property actually. Okay. There is a one theorem that is the uniqueness theorem of moment generating function. Obviously, the name itself says that the uniqueness, that means a random variable which follow a particular distribution has a fixed kind of moment generating function. Okay. So here the same case is going to happen, like the same case is happening. Okay. What is that? We know that if x follows the exponential distribution with the parameter, suppose theta, for example. Okay. Then in that case, the moment generating function is like 1 minus t upon theta inverse. Okay. This is the case. Now the question is, we can compare these two things, okay, because of the uniqueness theorem of MGF. Okay, we can compare these two and find out the value, like what? Like we are given this mxt can be written as like 1 minus t to the power 1 by 2 inverse. We can write like this. Okay, so after comparing, we will get theta equal to 1 by 2. And if theta equal to 1 by 2, then PDF will be like what? PDF will be like 1 by 2 e to the power minus x by 2. X is greater than 0. The parameter theta is already 1 by 2, which is greater than 0. So no need to write that. So this is the PDF for which this is the moment generating function. Now we know the PDF. Then the probability that x is greater than 1 is what? probability that x is greater than 1 to infinity half e to the power minus e to the power minus x by 2 dx. Okay, so that can be written as 1 minus probability 0 to 1 half e to the power minus x by 2 dx. These are the property of complementary event. Okay, probability of any complementary event is 1 minus probability of that event. So I'm using that concept only. So it's 1 minus half can be taken outside, and e to the power minus x by 2 is within this, then minus 2 is multiplied again, and then the whole power is 0 to 1. And yes, now you can solve. It comes out to be 1 minus 1 by root e minus 1. And at last, the probability that x is greater than 1 comes out to be, okay, this one is plus actually, not minus, 1 upon under root e. If anyone have any doubt, I can solve this as well. Okay, I'm just trying to recall all those topics that has been covered up to week 10. Okay, so this is the case. This is a simple now. This is just a integration. Integration of what? E to the power minus x by 2. E to the power x is actually e to the power x. So e to the power minus x by 2 is e to the power minus x by 2 divided by minus 1 by 2. That is actually multiplied into by 2 minus 2. So this is the case. Now you can put the value of x equal to 1. This is actually bracket and 0 upper limit minus lower limit, and solve this. You may find the final answer. Okay. If you people still any doubt, you people may ask. Okay, now the next question is actually based on the normal distribution. Okay, the normal distribution. That is also the case actually. So the mean weight of soldiers is 70 kg. We are given the question. The mean weight of soldiers is 70 kg with standard deviation of 4 kg. The standard deviation of 4 kg. In a regiment of 1,000 soldiers, the number of soldiers weighing more than 74 kg, the number of soldiers weighing more than 74 kg. Okay, assuming the distribution of weight is normal, 74 kg will be, you can write assuming the weight follows the normal distribution. Okay, I'm writing here the normal distribution with 70 kg and 4 square. Okay, the same meaning. Okay. Yes, we need to find the number of soldiers weighing more than 74 kg. Okay. So first we need to find the probability of soldier weighing more than 74 kg, and then we will multiply by 100 and find the expected number of soldiers that is weighing more than 74 kg. Okay, simple logic. So let's start with. So the question is clear. We are given x. X is actually random weight of soldiers. Okay. Also, we are given x follows the normal distribution with mu equal to 70 and sigma square equal to 4 square. Okay, this is given. We need to find the probability. We need to find the probability that x is greater than 74. You remember that when we are going to deal with the problem related to normal distribution, we need to first standardize the random variable. Okay, and then we will use normal table. This is the standard process when you are going to deal with normal kind of problem. So yes, it's probability that x minus mu upon sigma greater than 74 minus mu is 70 upon sigma is 4. So it is actually probability that z is greater than 1. 74 minus 70 comes out to be 1. Sorry, 4. 4 by 4 comes out to be 1. So this is the case. Now, if you remember the curve that I have drawn in week 5, perhaps 4 or 5, not sure. I think week 5. Okay, you may find the probability of this event directly. If not, you may use the table. Let me draw the table for here. Okay, suppose it's a normal table. It's a kind of symmetric table. Obviously, it's a symmetric table. And it is Z table actually. So Z equal to 0 is there. Z equal to 1 is there. Z equal to 2 is there. Z equal to 3. Minus 1, it's minus 2. Okay, let me write. So suppose minus 3. Suppose it's a normal curve. Okay. Suppose it's a normal curve. It's not looking like normal, but it's suppose it's a normal curve. Okay. So minus 3, and this is the case. Now the question is probability Z is greater than 1. So Z is greater than 1 means what? Z is greater than 1 means this probability. So obviously, this probability is 100% less than half because it's a symmetrical in nature. Okay. So you may use the normal table. You will find that this area is the area under this is actually 0.5, and this probability, the area under 0 to mu is actually it's like 0.3413. Well, yes, 0.3413 actually. Okay, you may use your table, writing here like probability that z is greater than 0, sorry, greater than 1 is actually probability that z, I'm writing this, 0.5 actually, 0.5 minus this probability, minus probability that z lie within 0 to 1. If you have this table, then you can find this. This is actually 0.5 minus pi of 1, z equal to 1, obviously. This pi is actually the CDF. So it gives 0.5 minus 0.3413. So probability that x is greater than 74 comes out to be 0.15, it's 8987, 0.87. Okay, so this is the required probability. Okay, now the question is how many soldiers in a regiment of 1000 soldiers is weighing more than 74 kg? So this is the probability that a soldier is weighing more than 74 kg. So out of 1000, so the required number of soldier is 1000 multiplied by 0.1587, that equals what? 158.7. Obviously, it's approximately 159. So this is our final answer. Okay. Any doubt up to this question? Okay, the next question. The next question is actually okay. The next question is like a very good question actually. So it is given like if x follows, where should I write follow? X follows log normal distribution with the parameter mu and sigma square. It's not mean and variance, it's parameter. Okay. In normal distribution, the mean and the variance are nothing but the parameter, the two parameter itself. But in most of the cases, parameter is a different thing and the mean and variance is different. Okay. So if x follows log normal distribution with parameter mu and sigma square, then the question is then what is the PDF of y, the random variable y, which is defined as log of x. Okay, so it's a simple question of transformation actually. So here we are given x follows log normal distribution with parameter mu and sigma square. Okay, so obviously the PDF for this is like 1 upon x sigma root 2 pi e to the power minus 1 by 2. Instead of using x, we will use log x. Okay, log x minus mu upon sigma whole square. Okay, so this is the case. Now, the next is we are given actually y equal to log x. This implies x equal to e to the power y. Okay, also dx upon dy is what? E to the power y again. Okay, so this is actually our Jacobian. Okay, this is our Jacobian, and you know the formula. Formula is what? Fy of y is equal to nothing but fx of x is a function of which is a function of y into Jacobian. Okay, so this is the case. So yes, it's Fy of y is what? Fx. Fx is this quantity 1 by this whole quantity. Then we use x equal to e to the power y. Okay, we use the functional form of x in terms of y here. Okay, not x. So it's what? So it's 1 upon x. So that means e to the power y into sigma into root 2 pi. Then exp or e to the power minus half log x. Log x can be termed as y. Log x can be termed as y. So e to the power minus half log s is y minus mu upon sigma whole square. And yes, everyone know this is nothing but the probability mass function for the normal distribution with mean mu and variance sigma square. Okay, so that means what? That means what? Y, which is equal to log x, actually follows normal distribution with parameter, the same parameter mu and sigma square. Here in normal case, it is actually mean and variance as well. Okay, so yes, this is the case. Is it okay up to this point? Hope so. It's okay up to this point. There is one more question. This question is yes. Anyone have any doubt? Okay. Then okay, thank you. Okay. The next question I'm going to write. This is also an interesting question. The question is assume that the maximum price of commodity, like right? Assume that the maximum price of a commodity on a given day have normal distribution. have a normal distribution with mean mu and variance sigma square. The shortest interval. Now the question is the shortest interval. The shortest interval that has the probability that has the probability uh, 0.95, that is 95% probability, okay, of including the maximum price. Maximum price for the commodity is the simple question. We are given this question and we need to find the shortest interval. That means this question is nothing but belongs to the confidence interval. Okay. So the question is, we are given it follows the normal distribution with mean mu and variance sigma square. Now the question is, we need to construct the 95% confidence interval for that. Okay, that means we need to construct the confidence interval that has the probability of 95% of including the highest or the maximum price of the commodity. Simple question. So we are given like what now? Here x follows normal distribution with mean mu and variance sigma square. This is the case. Okay. Now what? Let the shortest interval be like it's mu minus k to mu plus k. Okay. We have considered this because the shortest interval has equal deviation from origin actually. Okay. That must be or equidistant from the origin. That contain the maximum probability in minimum distance. So that is the shortest interval actually. Okay. So this is the case. Now let me solve the question. This is the case. So what? The probability that mu minus k x, it's mu plus k. This probability is given this. Simple. Now it is again belongs to the normal distribution. So the next step is to standardize this variable. Okay. So yes, it's mu minus k, sorry, minus mu upon sigma. It's z. X minus mu upon sigma can be directly written as z. It's mu plus k minus mu upon sigma equal to 0.95. Simple up to this point. So it's again probability that what? That minus k by sigma z, it's plus k by sigma equal to 0.95. Now this is the probability. So obviously it's phi z. So z equal to minus phi of minus k by sigma. Now you need to recall all the properties of normal distribution and obviously the standard normal distribution as well, the table as well. Okay. So that means actually what? This is actually means, let me write here. This is actually means what? Z is less than k by sigma. Okay. Minus, this is actually what? Z is less than minus k by sigma. Okay. So, okay. Suppose it's a normal distribution. So you know na, it's agar like it's if it is z then and it is minus z, then probability This area probability and this area probability is same because it is a symmetric distribution. So that means I can say, or I can write, that means I can write like this. Na? This can be written as like what? Phi of z is less than k by sigma minus phi of z is greater than plus k by sigma. Z is less than minus k by sigma is actually equal to z is greater than plus k by sigma equal to 0.95. Again, the next step is like phi z is greater than k by sigma minus this can be written as like what 1 minus phi z is less than k by sigma less than or equal to you can write. Okay, this is equal to 0.95. Now we can expand. So we may find that this quantity and this quantity sum up to twice of that. So that means it's twice of phi of z greater than k by sigma minus 1 equal to 0.95. So it's twice of phi of z is less than k by sigma equal to 1.95. Then phi of z is less than k by sigma. Simple transformation, nothing else. It's 0.975. Up to this point, everything looks good. Now, the next part is we need to find the value in normal table for which the near probability or the exact or the near value up to this probability value. Okay, 0.975. Then you will find this. Since you will find that the probability that z is less than 1.96 will have the probability this. Okay. So you may directly find this. So the from by comparing these, we get k by sigma comes out to be 1.96. So that means k equal to 1.96 times of k. Okay, it's sigma, na? Okay. So our interval will be it's mu minus k to mu plus k, which is equal to actually mu minus 1.96 sigma to mu plus 1.96 sigma. And you already know this is the normal table, these kind of we have already discussed actually. So this is the case. Okay. Any doubt up to this point? Okay. So we will solve next question then. This is the joint moment generating function related question. Okay. The question is if the joint moment generating function, question is if the joint moment generating function of a random variable of random variables of random variables x and y is we are given the joint MGF of random variable x and y is given like e to the power it's s plus 3t plus 2s square plus 18t square plus 12st. This is the joint moment generating function. Okay. We need to find the covariance between the random variable x and y. Find covariance between x and y. Okay. Just try to solve this. Okay. See, first we need to know that what characteristics, functional form or the statistical characteristics we need to know to find the covariance. We know that covariance between the random variable x and y is expected value of xy minus expected value of x into expected value of y. This is the formula. So that means we need to find the expected value of x, then expected value of y, and then the expected value of xy. Or you can directly first find the like the mean value of x, the mean value of y, okay, and then mean value of xy. For that, you need to know the distribution of x, the marginal distribution of x, the marginal distribution of y, and the joint distribution of xy. Or you can directly use the homogeneity function for properties. The properties is saying like the expected value of x is actually the derivative of this at s and t both equals 0, 0. This is the property. No? This can be discussed. This has already been discussed actually. So yes, this we can directly solve this now. Del s, okay, e to the power, it's what? It is like e to the power s plus 3t plus 2s square plus 80t square plus 12st. Okay, so e to the power x, the differentiation of e to the power x is obviously e to the power x. So that means what? E to the power, it's like s plus 3t plus 2s square plus 18t square plus 12st. Okay, this is the case. Into this term is multiplied by uh, obviously s, so it gives 1 plus 0 plus 4s plus 0 plus 12t. Okay, now the value at 0, 0, no? The value at 0, 0. Okay, so the value at 0, 0 will be like, so e to the power what? It's 0. Every term contains some s or t, so it's 0 multiplied by its 1. So directly you can solve the expected value of x is 1. In the same manner, you will solve the expected value of y. So the expected value of y will be like the same concept del t, okay, del by del t of again e to the power s plus 3t plus 2s square plus 18t square plus 12st. Now, the same thing e to the power, the same number s plus 3t plus 2s square plus 18t square plus 12st multiplied by what? It's 0 plus 3 plus 0 plus 36t plus 12. Sorry, plus 12. Okay, putting the value 0, 0 again, we will get e to the power 0. Okay, then multiplied by 3. So comes out to be expected value of y equal to 3. Now the next step is to find the expected value of xy. Again, the same thing, del 2 of del s del t and e to the power, it's what? It's s plus 3t plus 2s square plus 18t square plus 12st. Okay, at 0, 0 obviously. Then you can solve this. Okay, these are like the multiplication rule. We will apply the multiplication rule and find out the final term. I'm going to write the final term actually. Okay, let me write. Otherwise, it's not going to be good. So it's like what? First, let me define with t. So it's obviously e to the power some term multiplied by it's like 0 plus 3 plus okay, 0 plus 3 plus 0 plus 3060 plus 12. Okay, this is the case. Now the next step is now it's a product form. Now it is in product form actually. Okay, so I need to differentiate this. So we need to apply the product rule. The next step is the first one is e to the power the same number. The like it's like what? No? S plus 3t plus 2s square plus 18 square plus 12s square multiplied by with s. If it is with s, then it's 1 plus 0 plus 4s plus 0 plus 12t. Okay, this is multiplied by the second term itself. The second term is actually 3 plus 3060 plus 12s. Is it simple now to this point? Just the product rule. And let me so see, this is the term. I am first going to differentiate it with del t. So that is this term e to the power x is actually e to the power x. Then this quantity. Okay. Now this whole quantity is actually product term e to the power x into some other functional form. Now I need to differentiate it, partially differentiate it with s. So the first term is this, then this multiplied by the second term. Now plus, now plus e to the power the term has already been written directly. Okay, the same term that is on the first term. Then with s, it's actually 12 only because this number has only 12s as a function of s. So it's 12 only. The rest is comes out to be 0. So overall, putting the value s and t equal to 0, what we will find? E to the power all the terms, so e to the power 0. Then multiplied by 1 plus, it's only 1, into multiplied by 3 plus e to the power something is 0 multiplied by 12. So it comes out to be what? 3 plus 12, which is expected value of xy comes out to be 15. Simple. Now our aim is to find the covariance between the xy, which is actually expected value of xy minus expected value of x into expected value of y. Then expected value of xy equal to 15 minus expected value of x comes out to be 1. Expected value of y is 3. So it's 1 into 3, which is equal to 15 minus 3. So covariance between the term xy is actually 12. This is our final answer. Is it okay? Is there any doubt? If not, let me solve one more question. Okay, I have some more question actually. So let me solve one or two more questions, then we will end our session here. Okay, the question is we have x and y have the joint PDF. Let x and y have joint PDF. The PDF is like fxy equal to 2 when 0 is less than or equal to x is than equal to y equal to 1. Okay, we need to find the mean and variance of this. What this means? Find expected value of y given x equal to half and variance of y given x equal to half. We need to find this term. Okay. So yes, this is the conditional expectation. So before proceeding with the conditional expectation, we need to know how to proceed to find the conditional expectation. Okay. So the first thing is what? The first thing is we need to know the y given x. We need to know the probability density function of y given x. It's y given x. Okay, I just try to write the standard notation actually. This is the standard notation. The probability density function of the random variable y given x is equal to small x. Okay, this is the standard notation actually. And this is what? Again, the same a given b is a intersection then. So it's what? It's xy. It's divided by x. Simple. So the first thing is to know the probability density function of x. So yes. So it's fx equal to actually integral over y. It's fxy dy. Okay. So the range of y is what? X to 1. So it's x to 1. It's 2. It's dy, not dx. Dy. And the range of x is 0 to 1. So yes, it's twice, it's y, it's 1, it's x. So our fx will be like what? Twice of 1 minus x. When x lies between 0 to 1. This is our probability density function. Okay, for the marginal distribution of x. Now we need to find the conditional distribution. So the conditional distribution of x is what? Fxy upon fx, it's fxy is equal to 2 upon fx is 1 upon 1 minus x. So our y given x equal to x is what? It's obviously 1 upon 1 minus x when x can take value from 0 to 1. Now the question gives that x equal to half. So we need to find the f of y given x equal to half. Just put the value of x equal to half in the general PDF. So you will find it actually 2. Okay. So our conditional distribution is 2. Like coincidentally, it again comes out to be 2. Okay. Now the expected value of y. Now the expected value of y given x equal to half is actually the integral over y. Okay. Integral over y. Oh, okay. There is one more difference actually. This I am writing incorrectly from here. This is not the case, na? This is not the case, na? I'm talking about y, na? So y is what? So y value is taken from 0 to 1, na? Sorry, x to 1, na? And when we took the value of x is equal to half, so it is half to y to 1. And it is again 2. Before writing 2, let y into 2 dy. So it's what? It's half to 1. 2 comes out to be this one, y. So it's 2, it's y square by 2, it's 1, it's half. So 2 will be cancelled out, it's 1 minus 1 by 4. So expected value of y given x equal to half comes out to be 3 by 4. This is the case. I hope this is clear up to this point. Just simple like integration. I'm not doing anything like a very complex something thing. Just using the concept, using the formula and solving, nothing else. Now again, we need to find the variance of y given x equal to half. And this can actually find out quite expected value of y given x equal to half the expected value of y square minus expected value of y given x equal to half whole square. The same thing now. Variance of x expected of x square minus expectation of x ka whole square. Okay. So this is the case. Now we need to find the expected value of y square given x is equal to half. This is again the same. It's y square. It's f of y given x is equal to half dy. Just need to solve. It's half to 1. It's y square into 2 dy. So obviously 2 will be taken outside. So it is y cube upon 3. It's 1 to half. So it's 2 by 3. It's 1 minus 1 by 8. So it's 2 by 3 into 7 by 8. Okay, so it's 14. Okay, it's 7 upon 12. So expected value of x, sorry. So the expected value of y square given x equal to half comes out to be 7 by 12. Now the variance of y given x is equal to half is actually 7 by 12 minus 3 by 4 square. 3 by 4 whole square, that is 7 by 12 minus 9 upon 16, 16, 32, 48, it's 4, it's 28. Okay, minus it's 27. So yes, the variance of y given x is equal to half comes out to be 1 by 48. This is our answer. The simple answer, just a calculation. Is there anyone that till when will this? Okay. Actually, the session will, the time has already passed. Okay, it's 6 to 8. I have some more question. Okay, then I'm not going to discuss those questions right now. I can write or provide the same question in our Google Drive. Okay, so let me stop here. Anyone have any doubt up to this point? You may ask here. Okay, because I have 2 or 3 more questions that will take around half an hour actually. Okay, so let's stop here. We will conclude our session here if no people have any doubt. Anyone have any doubt up to this point? Okay, let me rate what you have written. If I completed all weekly assignments but haven't attended regular classes, will that be enough to prepare well for the final exam on this? See, you need to know the concept only. You don't need to think this much. You have not like you have completed all the assignment question. That means you know how to solve the question. That is the only motto actually. Okay, you need to see the classes. Obviously, you need to watch the lectures if you want. That is quite a comprehensive lecture. Okay, you may directly ask me some doubts if you have any kind of problem related to your assignments. But you don't need to be that much anxious about your exam. If you have solved all your assignment, then I'm sure you are able to solve the question in the examination as well. If you solve your exam, if you solve your assignment by yourself, okay. If you are using some direct chat GPT and all, then you may face some problem. So I'm based in Delhi and studying in a South Delhi college, which is a local chapter. Is it possible for my exam center to be allotted at my own college? Okay, this I do not have any idea. I can generally guess that there are some predefined centers. Okay, from there only you get you when you will get your hall ticket. Now you will finally get these information. I have no like involvement in these kind of things. My only work is to teach these things. Okay. Okay, thank you. Anyone else who have any kind of doubt or want to ask anything related to your examination or any kind of questions here? Okay, I think Ayush, you are still typing something. Okay, everything. If anyone
No,
like,
no, sir.
no.
It's enough. Thank you so much for,
Okay,
it's
okay,
enough.
thank you. Okay, thank you. Anyone else who have any doubt or should we conclude our session here? Okay, then I don't think, let me first stop the recording. Okay, then we will conclude our session. Okay, then thank you, everyone.
Thank you, sir. Thank you, sir.
Thank you.